Thank you, Dr. Bohan, and good afternoon to everyone listening and viewing the slides. It's a pleasure, as always, to be here. So today we're going to talk about detailed stratigraphy, and there's an image on the screen that I'll be referring to and walking you through as the lecture proceeds. So in our scenario with this Barracuda field, we've gone through the licensing round and bidded on blocks, especially if you've been doing the exercises. We've worked on the play elements. We've come up with a wildcat well location. Management's approved that, and we drilled a well and made a discovery. So we are now ready to move on to the development of this field. It's an offshore field, so that means something like an offshore platform needs to be built and installed and operated. There are a lot of questions that we face. Some of them are geoscience, but there's also engineering questions, economics, legal, finance, et cetera, et cetera. One main difference between exploration and development is the scale at which we do our analysis. People that are working in the exploration phase of an area, they look at a range of stratigraphic intervals. So they might be looking from the Miocene down to the Ordovician. And instead of looking at one block, they might be looking at an entire basin. When we're in the development phase, we know what the stratigraphic interval of interest is, or maybe there's 2 or 3 intervals. And so we have a much more limited area, the field itself, and a much more limited geological time range, the geologic age of the reservoirs that we are interested in producing. So development geoscientists have much more orientation on details. The explorationists can get by with some broad brush approaches, but in development and production, you have to be much more interested in the small stuff, small faults, small layers that could be impermeable, like shale, that's going to affect how the fluids are going to flow in the reservoir. When we're in exploration, we've perhaps mapped a number of horizons, shallow, intermediate, and deep. And they are adequate for evaluating the basin's hydrocarbon systems and to locating where to drill exploration wells or wildcat wells. The horizons are used to establish a basin scale stratigraphic framework. And now in the case with Barracuda, we have drilled a total of 5 wells. So we drilled the discovery well, and then we were asked or suggested that we drill some additional wells to verify that there is enough hydrocarbon there that we can make a profit if we build and install a platform. So for Barracuda, there was the initial well, and then 4 field development or field delineation wells that were drilled to verify things like the amount of oil, the amount of gas, how reservoir properties varied across the field area. As we get into the development of the field, we're going to need more stratigraphic detail. And if we want to do that so that we can decide, should we move this newly discovered field into the production stage where we're actually producing oil and gas, and also to develop and produce the field efficiently. So we want to know where the best place to put the wells, and perhaps instead of drilling 10 wells, if we are smart enough, maybe we can drain the field with only 8 wells. So in the field development phase, some of the things we want to do is try to get a refined picture of the distribution of the oil and gas. We want to know, is a reservoir a single unit in terms of producing fluids, or is it segmented, or another way to say that is it's separated into different compartments, each of which is going to have to be drained. And that's segmentation might be vertical into different zones, good zones and bad zones. It also could be segmented laterally from one fault segment to another. We also are interested in how many wells do we think we're going to have to drill, and where should we position those wells? What sort of a facility do we need? If we're offshore, maybe it's a platform, maybe we need 2 platforms in order to drain the field and maximize our profits. Our managers and our stockholders are always interested in speeding up the time till the first barrel of oil is produced, so that we can start to get some payback for all the money that we've invested in this field up to this point. And then what uncertainties still remain, things that we don't know that might impact our business decisions. So for Barracuda, the main reservoir is deposited during a major marine transgression. So for the width of Barracuda field, the earlier part of the reservoir is fluvial rocks, and it has some coals interbedded with it. As time progresses, we get subsidence, we get some more sediment. We start to see on the southeast some nearshore sands as opposed to fluvial sands. And as time continues, the extent of those nearshore sands extends further and further towards the northwest. And eventually we start to get some offshore shales. And so these would not be reservoir, and these could be barriers or baffles to flow that we're trying to produce the oil and gas out of the Barracuda field. So here's a portion of the stratigraphic column. So our reservoir is in the Latrobe Formation, and we have a fluvial component, kind of the orangey color here. We have nearshore sands, which is the yellow, and then we have offshore shales, which is called the Gunard Formation. So for the extent of the Barracuda field, we have fluvial sands, and they are referred to as the Barracuda Formation. We have nearshore sands. You can think about beaches. That's the Kingfish Formation. And then we have offshore silts and shales, and that's the Gunard Formation. And so in Barracuda, the TCC stands for the top of the coarse clastics. That's the top of the reservoir, whether it's fluvial sands or nearshore sands. And before we get to the top Latrobe unconformity, TOL, we have an interval, I think it's on the order of 10 meters thick, that is part of this Gunard offshore shale or shelf mudstones. So here is a seismic line from the 3D survey. It's through the location of the Barracuda 1 well. And for exploration, what they had mapped, and if you did the exercise, probably what you mapped, was a top of the reservoir shown here in the light green, and a base of the reservoir shown here in red. So that's the gross stratigraphy, if you will. When we get into the production stage, we have to be more worried about details. And so here's the same seismic line, the same location of the well. The dashed green is the exploration top reservoir. The dashed red is the base. And the thinner solid colored lines are the horizons that were picked in the development phase to try to get as much detail out of the reservoir as possible. And what I'll do next is talk about some of the upper horizons here and then some of the lower horizons. So this exploration top reservoir was carried in a peak. We find out with the wells, once we make our well seismic tie, that the unconformity is where we go from black into white. It's the zero crossing from a positive number into a negative number. The top of the reservoir quality sand is the orange, and that's what we call the top of coarse clastic. And there's a 15-meter interval between the top of the unconformity and the top of the reservoir. So between the red horizon and the orange horizon is 15 meters of that Gunard Formation, offshore silts and shales. Another horizon was mapped here, the gold sequence boundary. That's the top of a coal interval or a coal seam. And then a green horizon, the base of this peak, close to a zero crossing. So zooming in on this portion, now we're worried about the red horizon, the orange horizon, the gold horizon, and the green horizon. And over here on the right tells me what type of a position on the seismic waveform it is. So the top Latrobe unconformity is at a zero crossing. The top of the coarse clastics or the top of the reservoir is on a minimum or a trough. The gold is on a zero crossing, and the green is in a minimum, a trough, or the white area on the black and white section. Looking a little deeper, we have a pink boundary. This is the base of the primary reservoir. It's carried in a minimum or in the white zone. We have the magenta carried on a minimum, and the cobalt blue also carried on a minimum. So instead of two horizons that the exploration team worked on, now we have 6 or 7 horizons that we want to map around and correlate. This is another line from the 3D survey. Here's the Barracuda well location. This cross line is perpendicular to the one we were just looking at. And if you see the red, where we go from black into white, it maps across something like that. You can see that this white cycle that has the orange in the middle and the gold at the base disappears. And this green on the white goes straight through. And so we've had some erosional downcutting. And so we have removed the top of the Latrobe on the right side of this slide. So we've removed the shallowest Gunard interval, and we've also removed some of the sands at the reservoir level. So this is the type of detail that we would find of interest and of importance. So we can zoom in on that, and again, this white disappears. The unconformity has cut down, and it's almost removed all of the section between orange and green, except for a few meters. And so knowing about that erosion can be very important when we're trying to plan where to position wells and also to get an accurate estimate of how much oil or gas is in this particular reservoir. So that kind of concludes my prepared statements. We've covered a lot of ground since the early summer when we started this. Next Thursday, 2 days from now, we're going to have 2 sessions, one at 2 o'clock Eastern time and one at 3 o'clock. At 2 o'clock, we'll talk about production geology and geophysics. And then at 3 Eastern time, we'll talk about report writing in industry. So I will turn it back over to Dr. Bohan and see if there are some questions either on today's material or material that we've covered in the past.
All right. Well, thank you so much, Fred. That was great. And I actually don't have any questions for you today, so we'll wait for a few moments. Okay, here's something from Patrick. And he says, where would you drill the production wells?
The production wells for this particular field, they had one platform near the crest of the structure, and they have about 10 wells, producing wells, I believe, that has been draining the field. This field was discovered about 1965, and it has been on production for over 45 years. Yeah, about 45 years, and they are still producing gas out of it.
Wow. Good question, Patrick. He has another one. How much more does an offshore field cost to develop than a land one?
An offshore field is going to be much more expensive because you need a base from which to operate. And so these days, to build a platform offshore in not super deep water, you're probably talking on the order of $1 to $2 billion to build it and install it and get it started up. So when you're talking on land, if you have access to the surface, which typically you will do, then it's much less expensive to be able to put in the wells that you want.
Another good question, Patrick. Does anyone else have anything to ask? Well, we have Fred on the line. Going. All right. Well, thank you very much. Once again, a wonderful presentation. And just as a reminder, there are going to be 2 sessions on Thursday, the production and then reports in industry. So please join us for that. And once again, thank you so much, Fred. We really appreciate everything that you do and sharing your expertise with us.
Okay, well, I enjoyed doing it. I wish everyone a wonderful rest of the day.
Same to you. Take care, everyone. Bye-bye.
Thank you. Bye-bye.